Hello viewers, welcome back to Electrology. In today's video, we are going to understand standby earth fault protection, its operation and its construction. So, let's get started. First, let's understand what standby earth fault protection is. Standby earth fault protection is nothing but earth fault protection used to protect the generator and transformer from earth faults. In an electrical power system, faults occur due to various factors such as natural disturbances, lightning on the transmission lines, falling trees on the transmission lines, animals falling on insulators, insulation failure, cable failure, and electrical equipment failure, among others. These faults are classified into two categories: symmetrical faults like triple line to ground faults, and asymmetrical faults like single line to ground, line to line, and double line to ground faults. This protection scheme ensures the protection of equipment from any asymmetrical fault by detecting any unbalanced current in a three-phase system. It acts if the value reaches a predetermined threshold. In this video, we will briefly describe it, but before we dive in, I request that you check out the thanks and join buttons below. Your support through these will motivate us to bring more electrical engineering related topics and help us improve the channel. Now, let's discuss why it is called standby earth fault relay. Basically, it serves as backup protection for the restricted earth fault protection. It operates the circuit breaker when the REF protection fails to trip the circuit breaker during heavy earth faults inside the REF protective zone or any other earth faults. Simply put, it is standby protection for all earth faults. Now, let's look at the circuit diagram of standby earth fault protection. A current transformer is installed on the neutral side of the transformer or alternator. The current reference is taken from the neutral CT to the relay. An overcurrent element on the relay is directly connected to the CT reference. If you look at the image, you can see that the NCT or neutral current transformer is specifically used for standby earth fault protection. Now let's understand the working principle of standby earth fault protection. Consider the currents in the three phases are I1, I2, and I3, and the neutral current is IN. Under normal conditions, there is no current flow in the neutral. By applying Kirchhoff's current law, we can determine that IN equals I1 plus I2 plus I3. In normal conditions, the magnitude of the current in all the phases is the same, but they are 120 degrees apart from each other. For instance, if the current in the R phase is 100 amps at 0 degrees, the Y phase is 100 amps at 120 degrees, and the B phase is 100 amps at 240 degrees, then IN will be the vector sum of all these currents, which equals 0. However, practically, it's not always possible for the values of the currents to be exactly the same. So the summation of these currents will not be 0, and a small amount of current will flow through the neutral under normal conditions. But this may trip the circuit. To avoid spurious tripping, the relay is set at 10 to 20% of the equipment's rated current. Now, what happens if a fault occurs? During abnormal conditions, for example, if there is a fault in the R phase, the fault current will also flow through the neutral. The current transformer reads this fault current, and if it exceeds the preset value, the relay operates, sending a trip command to the circuit breaker to isolate the faulty equipment from the rest of the system. So that's all about standby earth fault protection, its operation, and its construction. I hope you found this explanation helpful. If you enjoyed this video and found it useful, please hit the like button and consider subscribing to the channel for more content like this. If you have any queries or suggestions, feel free to drop them in the comments below. And again, don't forget to check out the thanks and join buttons to support the channel. Thank you for watching, and see you in the next video.